There is a volcanic rock that, when ground to powder and spread on depleted soil, provides 65 minerals that synthetic fertilizers never replace. A German chemist named Julius Hensel discovered this in 1894 and called his book Bread from Stones. The fertilizer industry arrived within a decade. Science Direct has published peer-reviewed research confirming the effect. The synthetic fertilizer market is worth $200 billion. The rock has no patent. Why did we buy the bag instead? Two things explain why a soil amendment that provides 65 plant essential minerals weathers slowly into the soil over years, improving it with each passing season, and was documented in peer-reviewed form beginning in the 19th century, remains largely unknown to the average home gardener, who buys a $40 bag of synthetic fertilizer every spring. One involves what volcanic basalt actually contains, and what happens when those minerals are slowly released into depleted agricultural soil. Over years, rather than dumped all at once in a soluble chemical form, the other involves the fundamental incompatibility between a material that improves soil permanently and an industry that needs to sell you something every season. By the end of this video, you will understand the chemistry, the history, and exactly how to use this in your own garden. For less than the price of one bag of synthetic fertilizer, the place to start is not with the rock. It is with what the rock replaces, and why what it replaces was never adequate in the first place. When a modern synthetic fertilizer bag is labeled NPK, nitrogen, phosphorus, potassium, those three letters represent the entire nutritional philosophy of industrial agriculture. Identify the three macronutrients that limit crop yield in the short term, synthesize or mine them at industrial scale. Concentrate them into soluble forms that plant roots can absorb immediately. Apply them to soil and measure the yield response. The system works in the narrow sense that it produces crops in the season of application. It does not work in the broader sense that it builds soil. Because providing three soluble nutrients and nothing else is not feeding a plant the way a forest or a prairie feeds the plants growing in it for centuries, without any external input. Think about what natural soil actually provides. A forest that has never been cleared, never been plowed, never received a bag of anything, produces trees of immense size and vitality year after year. Because the geological minerals released by rock weathering over thousands of years are present in the soil. Profile at concentrations that support complete plant nutrition. Every element a tree needs is there, dissolved in soil water at the concentrations required, delivered to the roots through the fungal networks that extend the root's effective reach into the mineral matrix of the surrounding soil. The tree does not have a nitrogen deficiency because the nitrogen cycle running through the soil biology is complete. It does not have a calcium deficiency because the calcium is there, weathered out of the rock that formed the soil. It does not have a manganese deficiency or a zinc deficiency or a boron deficiency because all of these elements are present in the mineral-rich soil that a geological timescale of rock weathering has produced. Cultivated agricultural soil, farmed continuously for generations without mineral replacement, becomes the opposite of this. Crops remove minerals with every harvest. The minerals leave the field in the food. Rain leaches what remains. Tillage disrupts the fungal networks that would otherwise help retain and cycle minerals within the system. After enough seasons of extraction without replacement, what remains is physically present soil with the mineral richness stripped out of it, a substrate that can be made to grow crops only by continuously supplying the most immediately limiting nutrients in soluble form. The NPK bag is the industrial system's answer to a problem that the industrial system created. Plants require between 17 and 22 elements for complete nutrition, depending on the species. Of those, 3 are provided by air and water, carbon, hydrogen, and oxygen. The remaining elements must come from the soil. Macronutrients, including nitrogen, phosphorus, potassium, calcium, magnesium, and sulfur, are needed in large amounts. Micronutrients, including iron, manganese, zinc, copper, boron, molybdenum, and others, are needed in smaller amounts, but are essential for specific enzymatic reactions and biological functions that the plant cannot perform without them. Industrial agriculture provides 3 NHL. Natural volcanic soil provides 5. That gap is what Julius Hensel spent his career trying to close. And that gap is what the fertilizer industry has spent 130 years making sure you never thought about. Hensel was a German chemist who had been studying agricultural soils across Europe, and who noticed a pattern that the conventional agricultural wisdom of his era could not explain. The most productive agricultural land in Europe, the soil that produced the largest crops with the least external input, generation after generation, century after century without exhaustion, was consistently the soil that sat over or near volcanic rock formations, the Rhine Valley, certain regions of Italy, the volcanic highlands of Central Europe, where farming families had grown food on the same plots for generations, without the declining yields that plagued fields on older, more weathered geological formations. These soils were not more productive because they received more fertilizer or more skilled management. They were more productive because the rock beneath and within them was slowly weathering, releasing a continuous supply of minerals into the soil profile as rainwater and soil acids dissolved the silicate mineral matrix of the volcanic material beneath the topsoil. Hensel was not the first person to notice this. Every traditional farming culture that developed on volcanic soil in Hawaii, in the Andes, in the volcanic highlands of Central Africa, in Iceland, in Java, understood empirically that volcanic soil was uniquely productive soil. They did not know the chemistry. They knew the observation. The volcanic soil grew more food more reliably over longer periods than any other soil type they encountered. Hensel was among the first to attempt to extract the principle from the geological context and apply it to agricultural land that was not naturally volcanic. If volcanic soil was productive because volcanic rock released 65 minerals as it weathered, then, taking volcanic rock, grinding it to powder to accelerate the weathering surface area, and spreading it on depleted agricultural soil should replicate the productive conditions of volcanic soil. Not in a generation, but progressively over years, as the ground rock continued to weather and release its mineral content into the soil it was incorporated into. He called the book Bread from Stones because he was proposing, quite literally, to grow food from ground rock. Stay with me, because what researchers found when they tested Hensel's proposal is the part worth $200 billion to keep quiet. In 2022, Science Direct published a comprehensive review in the journal Science of the Total Environment, examining decades of research into silicate rock powder applications in agriculture. The review, titled Remineralizing Soils: The Agricultural Usage of Silicate Rock Powders, analyzed 48 crop trials across different soil types, climates, and rock powder compositions. The findings confirmed what Hensel had argued in 1894. Basalt and other mafic volcanic rocks provided multinutrient benefits to depleted soils that synthetic fertilizer applications could not replicate. The benefits were most pronounced in tropical soils and highly weathered agricultural soils, precisely the soils that have been most intensively farmed and therefore most mineralogically depleted. A separate review published the same year across multiple studies confirmed that basalt and volcanic rocks generally outperformed granite and other rock types in agricultural trials, with the highest mineral release rates and the most consistent crop yield improvements. A 2024 field study published in MDPI examining basalt rock dust applications on 2 organic farms found strong increases in plant-available calcium, magnesium, and potassium in the treated plots compared to controls. With improvements in soil pH and measurable increases in soil microbial activity, the microbial finding is significant in a way that synthetic fertilizer research rarely addresses. Volcanic basalt contains paramagnetic minerals, iron-bearing compounds that respond to magnetic fields, and these minerals appear to support the growth and activity of soil microbial communities in ways that provide compounding benefits beyond the direct mineral supply. A more active soil microbial community converts organic matter into plant-available nutrients more efficiently, making the same amount of compost or organic matter produce more plant nutrition than it would in a mineralogically depleted, biologically depleted soil. This compounding effect is part of why volcanic soils keep producing without external inputs. They are not just delivering minerals, they are maintaining the biological infrastructure that makes mineral delivery possible. Here is where the story stops being about soil and starts being about money. Julius Hensel published Bread from Stones in 1894 and was initially taken seriously enough in European agricultural circles that his ideas were discussed, translated, and debated across multiple countries. An English translation appeared in 1894. The book circulated among farmers and agricultural reformers who recognized in Hensel's argument an explanation for the declining productivity they were observing on intensively farmed land. But the 1890s were also the decade when the emerging synthetic fertilizer industry was beginning to build its commercial infrastructure, and the timing created a conflict that was resolved entirely in favor of the industry. Fritz Haber would develop the Haber-Bosch ammonia synthesis process in 1909, enabling industrial-scale nitrogen fertilizer production from atmospheric nitrogen for the first time in history. The German chemical industry, which would become the foundation of the global agricultural chemical sector, was investing massively in synthetic nutrient production capacity. During exactly the period when Hensel was proposing that ground rock could do the job more completely and more permanently, by 1913, the first industrial Haber-Bosch plant was operational. Within 2 decades, synthetic nitrogen fertilizer was transforming agriculture across the industrialized world. The conflict of interest was structural and complete. A bag of synthetic fertilizer needs to be repurchased every season because the soluble nutrients it provides are consumed by crops or leached away by rain within months of application. The same nitrogen that a field needs this season needs to be reapplied next season because synthetic fertilizer does not build soil nitrogen cycling capacity, it bypasses it. The same phosphorus, the same potassium, every season, the same purchase, the same receipt, the same revenue for the manufacturer. A ton of basalt rock dust applied to a garden or field weathers slowly over years, releasing minerals continuously as soil acids and microbial activity break down the silicate mineral matrix. A single application can improve soil mineral status for a decade or longer under appropriate conditions. The manufacturer sells it once. The customer may not need to purchase again for 5 or 10 years. From the perspective of a company whose revenue model depends on annual fertilizer sales from every customer, a material that reduces those purchases for a decade from a single investment is not merely a less profitable product, it is the wrong business model entirely. Hensel's book went out of print. The agricultural extension systems built in close partnership with the emerging agricultural chemical industry did not include remineralization with rock dust in their educational curricula. The 3-nutrient NPK model became the foundational framework of modern agronomy, not because it was the most complete model of soil nutrition available, but because it was the model most compatible with industrial-scale product sales. A model that told farmers their soil needed a bag of 3 nutrients every spring was a model that sold bags of 3 nutrients every spring. A model that told farmers their soil needed ground volcanic rock once a decade was a model that sold bags once a decade, and no industry was built around it. The volcanic rock that provided those 65 minerals through natural weathering was classified as a geological curiosity rather than an agricultural input. Of interest to geologists, but not to farmers or their suppliers. Here is what you actually need to know about using basalt rock dust in your own garden and what the research tells us about what to expect. Basalt rock dust is available from quarry operations across North America and Europe, where the byproduct of basalt crushing for road construction produces fine powder that quarries have historically paid to dispose of. Type basalt rock dust near me or volcanic rock dust garden into any search engine and suppliers will appear within your region. The agricultural market for this byproduct has grown enough that some suppliers now bag and sell it specifically for garden and farm use. But it remains orders of magnitude cheaper per unit of mineral nutrition delivered than synthetic fertilizer. A 50-pound bag typically costs between $15 and $30 and treats a garden area that would require significantly more in synthetic fertilizer purchases over the same period. The material cannot be patented. The quarries did not develop it. They discovered they had a waste product that organic farmers were willing to pay for, and the price reflects that. It is priced as agricultural byproduct, not as branded horticultural product. The application rate for garden use is typically between 5 and 10 pounds per 100 square feet of bed area, worked into the top 6 inches of soil or applied as a top dressing. Unlike synthetic fertilizer, which can burn plant roots at excessive concentrations because of its high solubility, basalt rock dust cannot be over-applied in any practical sense. The minerals release slowly through weathering, and the rate of release is governed by soil chemistry and biological activity rather than by concentration. You cannot create the salt burn problem that over-application of synthetic fertilizer produces, because basalt minerals are not soluble at the concentrations applied. The timeline of response is different from synthetic fertilizer, and this is the honest expectation to set. Soluble synthetic fertilizer produces visible plant response within days of application because the NCA nutrients are immediately available. Basalt rock dust improves soil over seasons and years. As the mineral powder weathers, the first season after application, you will see some response, particularly in soils that are severely mineralogically depleted. As the finest particle fractions begin to dissolve and release their mineral content, the second and third seasons show more pronounced improvement as the weathering process continues, and as the improved mineral status of the soil supports better microbial activity and better nutrient cycling from organic matter. By the third year in many soils, the difference between a remineralized plot and an unremineralized control plot, treated only with synthetic NPK, is measurable and visible. This is the fundamental difference between feeding the plant and building the soil. Synthetic fertilizer feeds the plant in the season it is applied and leaves the soil no more capable of feeding the next plant without another application. Basalt rock dust builds the soil over years in a way that makes the same soil produce more with every passing season. Rather than requiring more external input to maintain the same output, it is the difference between a subscription and a purchase. The fertilizer industry sells subscriptions. The rock is a one-time purchase that the quarry cannot mark up for brand value, cannot reformulate with proprietary additives, and cannot patent. One honest note worth including: the research confirms that basalt performs best in highly weathered tropical soils and nutrient-depleted agricultural soils, and that results in temperate soils with existing mineral reserves are more variable and sometimes inconclusive in short-term trials. In a garden soil with reasonable existing mineral content and active compost additions, basalt rock dust is a beneficial supplement, but not a dramatic overnight transformation. The dramatic transformations documented in research occur in soils that have been farmed continuously without mineral replacement for decades, where the mineralogical depletion is severe enough that the basalt is addressing a genuine deficiency rather than merely supplementing an adequate baseline. The research is honest about this, even if the marketing materials for commercial rock dust products sometimes are not. If you have been gardening in the same soil for years, adding compost annually but never adding mineral inputs, basalt rock dust is likely the most significant missing component in your soil management program. The compost feeds the biology. The basalt feeds the soil, the minerals the biology needs to work with. Together, they replicate more completely what volcanic soil does naturally than either does alone. Julius Hensel figured this out in 1894 and called it bread from stones. The fertilizer industry arrived and called it inconvenient. Peer-reviewed research published in Science Direct and MDPI has been confirming it for decades, increasingly urgently as the soil health consequences of a century of NPK-only management have become impossible to ignore. The bag on the shelf at the garden center still says NPK. The rock is still in the ground, still releasing minerals on its geological schedule into every volcanic soil on Earth that has not yet been told it needs a bag of 3 elements instead. The rock has no patent. It has no marketing budget. It does not have a sales representative who attends your local garden center's trade day. It has only been right for 130 years, confirmed by the research, demonstrated by the volcanic soils that never needed a bag in the first place, and ignored by the industry that needed you to keep buying one. If you found this genuinely useful, watch the next video and do not forget to subscribe. See you in the next one.